Hello and welcome to Lecture 6 Part B. In this section we will look at the statistics behind the control charts. It is important to understand the type of data that we are dealing with because in control charts the type of control chart we use will depend on the type of data that we are actually dealing with. We are going to be working with variable data. There are other types of data called attribute data, but that is beyond the scope of this course. Variable data is associated with measurements, for example, the thickness of a silicon layer, the weight, assembly time, length, temperature. These are all examples of variable data. In variable data, we can take measurements. There are other types of data called attribute data, and that involves count data, the number of absentees on a particular day, the number of injuries in a company, the number of non-conformities or defects, the number of non-conformances or defectives, similarly the number of incorrect orders. Attribute data involves counting. In this course we will only deal with variable data. However, the statistics behind control charts are the same for both the variable and attribute data. While the type of control chart may vary, how we interpret and plot the control chart is similar for both types of data. Before we can plot the control chart, we have to understand a number of aspects associated with our data. The first aspect relates to where the center of the data lies. There are three ways that we can describe the center or the middle of a set of data. First one is the average or the mean, the second one is the mode, and the third one is the median. The most common one is the average. And the average is simply determined by summing all the values and divided by the number of observations. There is a specific symbol associated with the mean and it's referred to as x bar. The bar on top refers to the average of the x's. So what this equation refers to is x bar, or the average of all the x's. We add up all the x's and we divide by the number of x's. This symbol here, Greek symbol, refers to the sum of all the x's. So we sum all the x's and we divide by n, the number of observations. Let's take an example. The number of children was recorded for 5 families and we have the data presented to us here. One family had 1 child, another family had 2 children, a third family had 3 children, a fourth family had 2 children, and a fifth family had 2 children. To find the average of the number of children per family, what we do is we add these up and we divide by 5 because there are 5 families, and we get the average of 2. So on average there are 2 children per family. Let's take an example of the mode. If we take the same data set, the mode refers to the value that appears most often. In this case it's the number of children that appears most frequently, and we see here that the one that occurs most frequently is 2, so the mode is 2. Let's take the example of the median. If we take the same set of data, the median refers to the value which is in the middle of the ordered set of data. So we arrange the values in ascending order. We have 1 first, followed by 3 2s, followed by 3. The value in the middle, which is here, is 2. So the median is 2. So the median number of children in a family based on this set of data is 2. In addition to understanding where the center lies, we also need to understand how variable is the data. There are 2 main measures for variability. One is the range and the other is the standard deviation. The simplest one to deal with is the range. Here we see 2 distributions. The second distribution is more widely spread out. The range represents the difference between the largest value and the smallest value. So the range of the first distribution is 5. The range of the second distribution is 10, 11 minus 1, which is 10. So we can see that the second distribution is twice as spread out or twice as variable as the first distribution. Let's take an example. Here we see the range represents the difference between the highest and lowest value. So if we're given a set of data 23, 22, 23, 25 and 24, we look for the largest value, which is 25, and the smallest value, which is 22, so the range is 3. Now the range works quite well when the number of data points is quite low. However, it does not work when the number of data points is large. And around 4 or 5, the range is an ideal measure for variability. Above that, the standard deviation should really be used. The normal distribution is an important distribution in control charts. The normal distribution has a distinctive bell-shaped curve. The center is in the mean, and the variability is measured by means of the standard deviation, sigma. We see here that 68% of the area under this bell-shaped curve lies between plus and minus 1 standard deviation above and below the mean. 95% of all measurements lie between values 2 standard deviations above the mean and 2 standard deviations below the mean. 99.73% lie between minus 3 standard deviations and plus 3 standard deviations above the mean. So there's a very small proportion, in total 0.27%, lies beyond 3 standard deviations. The normal distribution is quite useful in measurements, and a lot of measurements will follow the normal distribution. If we take the example of mice, let's suppose there's a species of mice whose tail length measures a mean of 10 centimeters and a standard deviation of 1 centimeter. What this implies is that 68% of all adult mice will have a tail length between 9 and 11 centimeters. 95% of all adult mice will have a tail length between 8 and 12 centimeters, and 99.73% will have a tail length between 7 and 13 centimeters. Only a very small portion will have a tail length either larger than 13 or smaller than 7 centimeters. So by means of these two parameters, the mean and standard deviation, we can actually characterize the tail lengths of mice. The central limit theorem is an important theorem in control charts. It implies that the distribution of x-bar values, in other words, the distribution of averages, will also be normally distributed and will have a mean equal to x-bar bar, or the average of all the averages. Its standard deviation will be sigma over the square root of n, where n represents the sample size. This holds true irrespective of the distribution of the individual values. The individual values may form a uniform distribution, but if we start plotting averages, those averages will form a normal distribution. Now, if we look more closely at this equation for standard deviation, we see that n is below the line. As n increases, the number below the line will increase, causing sigma x bar to decrease. So what it implies is that as the number of samples that we accumulate together and then get the average of, as that increases, then the spread of the averages will actually decrease. This concludes Lecture B on the statistics of control charts. We will now use these statistics to develop the control charts.